We will be investigating the area of analytic geometry involving parallel and perpendicular lines. Perpendicular lines are lines that meet at a 90-degree angle, and parallel lines are two lines which never touch. We'll be investigating this in the context of how their slopes interact with one another. For the purpose of this investigation, we'll be considering two lines, the line y equals m1x plus b1 and the line y equals m2x plus b2. We'll be using these variables to discuss how the two slopes of parallel and perpendicular lines compare with one another. Parallel lines will have the same slope. We express this using the formula m1 equals m2. Perpendicular lines will have slopes whose product is equal to -1. By dividing both sides of the equation by one slope, we instead have an equation where one slope is the negative reciprocal or the opposite reciprocal of the other. Take a quick moment and look at the equation of these two lines. What do you think? Are they parallel, perpendicular, or neither? In this example, the lines are in fact parallel because they have the same slope. How about these two lines? Are these two lines parallel, perpendicular, or neither? In this case, the two lines are perpendicular. We know that they're perpendicular because the product of their two slopes equals -1. You might have also recognized that -1/3 is the opposite reciprocal of 3. Oftentimes, however, we're not just looking at the equation of two lines to determine if they are parallel or not. We're using an equation to find a parallel or a perpendicular line. Take a look at this problem. In order to answer the question, we first need to know what is the slope of the line which we are going to be creating. Because we're looking for a parallel line, we take the slope of the line given, which in this case is 3. We then use the point-slope form of the equation of the line. We substitute the slope in the point given, simplify the expression, and then solve for y. This is the equation of the line which is parallel to the line given and passes through the point 1, 5. Suppose we just change one word of that previous example, parallel to perpendicular. In this case, we will determine the slope using the opposite reciprocal, which tells us that the slope will be -1/3. We then, once again, use the point-slope form of the equation of the line. We substitute the same point, but this time the slope is going to be different. Notice -1/3. We simplify, and once more solve for y. This is the equation of the line which is perpendicular to the equation given passing through the point 1, 5. Finally, here is a visual of all the lines we just looked at. The line in black was the original line, y equals 3x minus 12. The line in blue is the parallel line, 3x plus 2, and the line in red is the perpendicular line. Notice that the blue and red lines both pass through the point 1, 5 as directed by the instructions in the examples.